Exercise 6, Advanced Iteration Techniques, Recurrence Formulae, Part 1, Question 1. If in equals the integral of cos x to the power n dx for n greater than or equal to 0, show that in equals 1 over n sin x cos to the power n minus 1x plus n minus 1 on n in minus 2 for n greater than or equal to 2. Hence show that if in equals the integral between the limits of pi upon 2 of 0 of cos x to the power n dx for n greater than or equal to 0, then in equals n minus 1 on n in minus 2 for n greater than or equal to 2, and hence show that I4 equals 3 pi on 16. Okay, let's pause the video. Okay, now here is the solution. Okay, first of all, if you had seen the lesson for the sine power, and you do the same thing exactly. So in is equal to the integral of cos n minus 1x cos x dx, and using integration by parts formula, u to v equals uv minus the integral of v du. Your u equals cos n minus 1x, and my dv equals cos x, so du equals n minus 1 cos n minus 2x, and then differentiate cos x, you're going to get minus sin x. Integrating cos, you'll get sine. Just watch those signs. And of course, the integral in is going to be sin x cos n minus 1x. Now it'll be minus, but this will be a plus, so it'll be plus n minus 1 integral of cos n minus 2x, and sine times sine is sine squared dx. This is n minus 1 integral of cos n minus 2x 1 minus cos squared x dx, and that equals n minus 1. Now this one will be the in minus 2 minus n minus 1 in. We're multiplying that one and that one together. Alright, now take it across the other side. We get in plus n minus 1 in equals the sine of x cos n minus 1x plus n minus 1 in minus 2. This becomes just nin, so I'm dividing through by n, we get the result we're after. Sine x cos n minus 1x plus n minus 1 on n in minus 2. Right, we need to find out what the definite integral is. So putting pi upon 2 and 0 in there of cos n x dx, and that's going to be 1 on n into sine x cos n minus 1x in pi upon 2 and 0 plus n minus 1 on n in minus 2. Right, now the cos of 90 is 0, so it'll make it 0, and the sine of 90, the sine of 0 is 0, so this is all going to be 0. So this is just simply going to be n minus 1 on n in minus 2. Now to calculate I4 in this case, I4 is equal to be 3/4 of I2, and I2 is going to be 1/2 of I0. Now I0 is simply going to be equal to 1 dx, which is equal to x between pi upon 2 and 0, which is pi upon 2. I2 could be 1/2 of pi upon 2 or pi upon 4, which means that I4 must be 3/4 times pi upon 4, which is, as required, 3 pi upon 16. Right, number 2. If in equals the integral between 2 and 1 of log x to the power of n dx for n greater than or equal to 0, prove that in equals 2 times log 2 to the power n minus n in minus 1 for n greater than or equal to 1. Hence evaluate the integral between 2 and 1 of log x to the power of 3 dx in terms of log 2. Now just pause the video. Okay, now here's the solutions. We have that in equals integral between 2 and 1 of log x to the n dx. So I'm going to use integration by parts. U to v equals uv minus integral of v du. My u is a lot of this, log x to the n, and my to v equals 1. So du equals n log x to the n minus 1 times 1 on x. My v equals x. So in equals x log x to the n, all raised to the n, between 2 and 1, minus, now this would be, when you multiply those two together, they'll go out. So we're going to go n integral log x to the n minus 1 dx between 2 and 1. Okay, which equals, this will be 2 log 2 to the power n. Now when you put the 1 in there, that's going to be the log of 1, which is 0. So it'll be just 0 minus, and this of course is in minus 1. So there we have it. That's what we have to get. 2 log to the n minus n log, I'll just rewrite that a little bit better. 2 log 2 to the n minus n minus 1. Okay, now I3 is 2 log 2 to the power 3 minus 3I2. I2 is equal to 2 log 2 power 2 minus 2I1. I1 is equal to 2 log 2 minus I0. I0 is going to be equal to just the integral of 1 dx between 2 and 1, which is just 1. So this I1 is 2 log 2 minus 1. So I2 will be equal to 2 log 2 squared minus 4 log 2 plus 2, and I3 would be 2 log 2 cubed minus, now this will be 3 times this one, minus 6 log 2 squared plus 12 log 2, and that'll be minus 3 times 2 minus 6 is your final answer.